it. Give it to me.
So first, first off, you do a variable space.
Excellent.
First step I did was 35, 7 on both sides.
Ooh, love that for us. Let's multiply by 7 to both sides. Now, some people, JJ, I'm just going to say this like right now. Some people like to write it as 7 over 1, but that's the same thing as what you're saying, right? Because 7 over 1 is just 7. But they like to write it like this because it's easier for them to see, okay? How many people, when they started this problem, multiply by 7 over 1? Good, okay? How many people divided by 1/7? Okay, that's also fine, okay? But remember, when you divide fractions, it's keep, change, flip, right? So what I'm doing is I'm changing dividing to multiplication. And instead of dividing by 7 over 1, dividing by 1 over 7, I'm multiplying by 7 over 1, okay? So when we multiply by 7 over 1, what happens, JJ?
You cross out the 2 7s because they cancel each other out.
Beautiful.
And that would equal 1.
Mm-hmm.
But then that's not really, that would just equal x at the
Okay.
end.
Mm-hmm.
And then you put equal, and then 4 times 7 is 28.
Excellent.
So that's pretty much it.
Yeah, that's it. 1x equals 28, or just x equals 28. How many people got this before I went over it? Love to see it. Love to see it. Okay, take a look at number 2. A little bit trickier. Any ideas on number 2? Mina? Multiply by 8. That's a very good start, okay? Now, we're going to multiply by 8 over something else, though, because we want everything to cancel on the left. What do you think we should put 8 over?
1.
Nope. 3.
Let's go.
How many people multiply by 8 over 3? Good, okay? When we multiply both sides by 8 over 3, Amina, do you see why we multiply by 8 over 3? Can anyone explain why we multiply by 8 over 3? Liz?
Because it'll cancel out everything.
Exactly. Do you see how this was 3 over 8 and not 1 over 8?
It's like a reciprocal.
Reciprocal. Very good, okay? Vocab word. So whenever we multiply by the reciprocal, right, everything cancels. It's like the beauty of math is happening right now, okay? Really nice things happen when we multiply by the reciprocal. So we've got 1 and just x, so that's just x, equals, now, 5 over 8 times 8 over 3. Nick?
You cancel out the 8s.
I love that. Let's cancel out the 8s before we multiply. Now, you could have done 5 times 8 and 8 times 3 and gotten 40 over 24, right? But then you'd have to simplify. It's going to be messy, okay? Cancel out those 8s first. These both become 1s. And we're going to get... JJ?
15.
Nope.
Wait, my bad.
What is it?
It's...
Help him out, Jonathan.
5 over 3.
5 over 3. Because remember, we take 5 times 1, and we take 8 times 3.
Oh.
I'm sorry, 1 times 3.
Oh, my bad. I looked at cross multiplication.
When do we cross multiply? Only when there's an equal sign between them. Okay? When we multiply fractions, let's say we had, 7 over 10 times 8 over 3. When you multiply fractions, you multiply straight across. Okay? So the 7 and the 8 get multiplied, and the 10 and the 3 get multiplied. So 7 times 8 is what? 56. Thank you. My brain is shot. And 3 times 10? 30. Okay? And then you would have to simplify this, right? They're both even, so you could take out a 2, and so on and so forth, okay? All right. X is equal to 5 over 3. How many people got that one? Ayo, love to see it. Okay, moving on. Number 3, 1/2 equals negative 2 over 3. Brady? Excellent. Let's multiply by 3 over negative 2 to both sides. And if I do that, someone who also did that, tell me what I get on the left side. Yep.
3 over negative 6.
3 over, very close. It's not, negative 4. There we go. And then equals, these all cancel. Even the negative, okay? So we just get x. Easy, right?
Yes.
Now, let me show you guys something. This should come as a little bit of a review. If we have negative 3 over 4, negative 3 over 4, 3 over negative 4, and negative 3 over negative 4. If I told you all of these are equal to each other except for one, which one is not equal of those 4 that are on the board?
Negative 3 over 4. The second one?
Gio?
-3/9.
That's the oddball out. All three of these are equal to each other. Equals, equals. Why is -3/-4 not equal to the rest of them? Grace? It's going to end up being a positive. Because if you have two negatives divided by each other, right? And you divide them, you're always going to get a positive 3/4.
That's not bad.
Do you see it now, though?
Yeah, I see it.
See? Mistakes, we can learn from them, right? Growth mindset, people. Let's do this. Okay, we're on number 4. We've got 3/4 equals 1 minus 1/2 x. A lot of fractions, baby. We're not afraid of fractions anymore, are we? We're going to get so used to fractions. We're going to be so happy when I ask that on a quiz. Okay, so 3/4 equals 1 minus 1/2 x. What do you guys think I need to do? Grace? Hey, love to see it. How do we cancel out the 1, though? What operation are we going to use? Very good. We're going to subtract 1 from both sides. Now, before we jump into this and get 2/4, we can't get 2/4 yet. Why can we not just subtract 1 from 3? Nick?
Because it's not a fraction, and if we turn it into a fraction, we wouldn't have the same denominator.
Very good. We need to find that common denominator. Do you guys remember that? Because right now, 3/4 and 1 do not have a common denominator. 1 doesn't even have a denominator. So let's rewrite it as 3/4 minus 1 equals, this cancels, and we get -1/2 x on the right. You guys with me so far? All right, now we need to change that 1 into a fraction. Guys, what's the same as 1? Victor?
I have a question.
Go for it.
Why would you move the 1 to the left side of the equal sign?
Oh, great question. I love that question. Can anyone answer that for me? Why are we moving the 1 over? Grace?
We already canceled it out on the right side. We just started doing the transaction on the left side. So it's already
But why did we move it over in the first place? Rihanna?
because we want x by itself.
Very good. Do you see how x is on the right side? Everything on the right side except for x needs to go away. And we're going to see that in our lesson too. The reason we move the 1 over first is because 1 doesn't have an x on it. So it's like that annoying sibling that we need to get out of our room. You just kick him out, right? He's got no x, he's got no nothing. Just get him away. And then we're going to take care of the -1/2. Do you see that? So we're going to leave this as it is and just move it over second. Do you understand why we're subtracting now?
Because it's a negative, no?
It's a positive, and in order to get rid of a positive number, we need to subtract, okay? All right, great question. Okay, so what is the same as 1? Can we write 1 as a fraction, Gio? Yeah, you can go. Nick?
1/1.
1/1. But we still don't have a common denominator. What can we do to get a common denominator here? Liz?
You could multiply both of these by 4.
Yes, multiply both the top and the bottom by 4. So let's write times 4 times 4. So if we do that, we've got 3/4 minus 4/4 equals -1/2 x.
Would that equal 1/4 equals... Oh wait, never mind.
Okay, so what's 3/4 minus 4/4? Brady?
-1/4.
There it is. Do you see that, JJ?
Yeah, I do.
Who can explain why it's negative? Gabby?
Because 3 minus 4 is negative.
Very good. We're subtracting a bigger number, right? Whenever you subtract a bigger number, you're always going to get a negative result. So this equals -1/4 equals -1/2 x. Oh my gosh, guys, we're so close. We are one step away. Does anyone see the one tiny thing that we can do to solve for x? Brooke, do you see it?
Multiply by 2 over -1.
Love to hear it. Now, Brooke was super close. She's going to add one step if she doesn't multiply by this instead of 2/1. -2/1. Thank you very much. So let's multiply by -2/1. And -2/1 times -1/4. We take the two numerators, multiply them. What's -2 times -1?
2.
+2. And we take the denominators and multiply them. What's 1 times 4?
4.
2/4. Equals, these all cancel out. Boo. Yeah, baby. So we've got x and we've got 2/4. Does 2/4 simplify? Sure does, peeps. What does it simplify to?
1/2.
1/2. Love to see it. Yes.
How did you get 1/4?
How did I get 1/4? The negative 1/4?
Yeah.
Okay. So we had 3 over 4 minus 4 over 4, right?
Oh, okay.
So this is the same as 3 minus 4 all over 4.
Okay.
Okay? And then 3 minus 4 we know is negative 1, and that's how I got over there. I had to draw an arrow because I ran out of space. Okay? All right. Now, today is all about you guys because I love you so much. So you guys should start with, should we multiply everything by negative 6 or move the 7 away?
Move the 7 away.
Yes. Why move the 7 away first?
Because like you said, you want to get it away from the line.
It's like that annoying sibling, right? It has no why. It has no purpose. Get it away, okay? So what we're going to do is we're going to subtract 7. Oops, that's a highlighter. We're going to subtract 7 from both sides. Awesome, Victor. Love that. Love that for us. Okay, so we're going to cancel out the 7s. Boom. We've got y divided by negative 6 is less than, what's 9 minus 7, peeps? 2. Okay, now let's be very careful here. What can we do to solve for y on the left side? JJ?
Multiply -6 on both sides.
Oh my gosh, you're amazing. Okay, so we multiply by negative 6 on both sides. Once we do that, these cancel, and we get y is less than negative 12. Agree or disagree?
Agree.
I hear some people disagreeing. I'm so happy that you said disagree. What did I forget to do? Juan? I didn't switch it. How many people forgot that we got to switch our inequality sign? Why do I flip the sign? Why do I flip the sign here? Gabby? Yes, I divided by a negative number. I'm sorry, I multiplied by a negative number.
Wait, was that what the big box was?
Oh yeah, that's the big box. Do you remember when I said there is one thing and one thing only you need to remember from this lesson? When you multiply and divide by a negative number, multiply or divide, doesn't matter which one, you've got to flip your inequality. JJ, what's up? What? Next, okay, my apologies. Y is greater than negative 12. Let's graph it. So we're going to draw a number line. This is exactly how I want you to graph it on your quiz, okay? Here is 0. Where does negative 12 go?
To the left.
To the left. So we're going to put negative 12 over here. Open or closed circle?
Open.
Good. Open. Why?
Because it's going that way.
It's not equal to.
It's going this
It's not equal to. Can y be negative 12? No. Y has to be bigger than negative 12. And if y has to be bigger, which side are we shading? To the right or to the left? A la derecha. To the right. Now, if you're going to use the arrow method, right, where you're like, oh, my arrow's pointing to the right, so I know I'm going to shade to the right. What is the one thing you need to make sure? Carson? That your variable's on the left, okay? I have some tricks for you guys, but they only work in certain scenarios. Make sure if you're going to use one of my tricks, you pay attention to what I tell you, right? Otherwise, you got to know exactly what you're doing, okay? So y is anything bigger than negative 12. That's why we shaded to the right. Okay, next question. 2v minus 4 is greater than or equal to 8. Does anyone see, just by looking at this problem, what we should do first? Aya, go for it. Love it. We're going to add 4 to both sides. Boom, bada, bing. Now, who's really good with addition and can tell me what 8 plus 4 is? 12, thank you. So we got 12. And then we've got what on the left?
2v.
Just 2v. And my next step, peeps. Divide by 2. Excelente. And we're going to get v is greater than or equal to 6. Did I forget to flip the sign?
No.
Why did I not flip the sign here, peeps?
Because it's a positive.
Alex. I did not divide by a negative, okay? Even if that was negative 12 on the right and I divided by 2, as long as you divide by a positive number, nothing changes. We're sitting nice and pretty. Okay, so v is greater than or equal to 6. Now let's graph it. I need someone to walk me through exactly how they would graph it. Aurora, go.
So you write down the number line and then you put the 6 on the right, and then you have a closed circle over it, and then you shade to the right because it's greater than or equal to 6.
Oh my God, I love that for us, okay? So we're shading to the right. Now, if I were to tell you that Aurora would lose 1 point for her number line, why would she lose 1 point? Victor? She didn't put the 0. Does the 0 belong on the left side of 6 or to the right?
Huh?
No, it belongs in the middle.
It belongs on the left. It doesn't have to be exactly in the middle, but I just need to know that you know that 6 is bigger than 0.
Can we write it that way, or you want?
You can write it in the middle, absolutely, okay? You can write it however you want as long as it looks something like this,
I
okay?
don't want to do that on the test numbers.
Why is there a closed dot?
Because,
Nick?
Because the greater than or equal.
It's greater than or equal to, okay? How are we feeling so far? Gucci Marucci?
Good.
Okay, when I say cool beans, you say cool beans. Cool beans? Cool beans. Okay, moving on. Now we are on variables on both sides. Move all like terms to one side. Copy that down. And this will be our last thing that we're learning today.
Wow, that was the quickest lesson I ever.
We're not done. We're not done with this lesson. Very good. We need to subtract 2x. Do you see how the 2 is positive?
yeah,
But if we subtract 2, we're not going to get a bigger number than 6x, right?
yeah.
It's just going to become 4x, okay? So that will still keep everything positive. You're on the right track, okay? So we're going to subtract 2x from both sides. Boom, these cancel. And what's, oh, not 24. Wow, I'm in a mood today. Okay, what's 6x minus 2x? 4x, good. I am in rare form, guys. Is less than, and then we've still got 11 over here, okay? Now, there are still like terms that are not on the same side. What should we do next? Rihanna?
Add 5.
I love it. Add 5 to both sides. So we're going to get what? Nick?
4x is less than 16. You can divide 4 by. You can divide 4 on both sides.
Excelente.
X would give you
X would give me less than?
less than 4.
Oh, yes. We're doing it, peeps. That is the less than symbol. Sorry, it looks like a pirate's C. And then we draw a number line. We put 0 and we put 4. Victor, what are you asking?
So when you're gonna move the, like you said, the 2x, why would you move the 2x and not the 6x?
So, Victor, the reason I move the 2x is because I don't like negative numbers. So I want to move the smaller one over to the other side. Because if I subtracted both sides by 6x, you're going to get the same answer. Trust me, you will. Okay? But you're going to get negative 5 is less than negative 4x plus 11. And I don't like that negative 4x. I'd rather stay away from it. But hey, I want you to try it tonight. Put a little star next to this one. I want you to try by moving the 6x over and see if you get the same answer. Okay? All right. So we've got x is less than 4. So we've got 0, we've got 4. JJ, open or close circle?
Open circle,
And shading which way?
to the right, left. No, to the right, right? Wait, this is right.
Right is for greater than.
Yeah,
No, it's
to
for
the
less
left.
than.
To the left.
To the left, to the left. Everything you own in the box to the left. Someone explain to me in words that I haven't used, why do we shade to the left? Explain it in your own words. Jonathan, go for it.
I just used their arrow trick.
Oh, use my arrow trick? If you're going to use the arrow trick, what do you need to make sure?
The variables on the left.
The variables on the left side. Someone who didn't use the arrow trick. How can you explain this? Brady? So you look at it as x must be less than 4 at all times. All the values less than 4 lie over here. Could x be negative 1?
Yeah.
Yes. Could x be 0? Yes. Could x be 3? Could x be 4? No. Could x be 5? No. Do you see how everything that's not available for x is not shaded? Could x be 1,000,000? Could x be negative 1,000,000? Yes. Okay. All right, guys, take pictures and submit. All right, so the first example, okay, I'm going to spoil the surprise for you, is an example of no solution, okay? But let's see how we get there. Just by looking at this problem, who can tell me what light bulb goes off in my brain when I look at this problem? Carson?
Distribution.
A distribution. So what are we distributing? The 8 or the 4 or the 2 or the 3? What? Carson?
The 4 to
Ec-
2 and the 4 to the 3.
Excelente. The 4 is getting distributed to the 2b and to the 3. So who's good with distribution? Can tell me what I get on the right side. JJ, go for it.
So on the other side is going to be 8b minus 3 is greater than. Oh, yeah. Wait, is it cross 3?
No, that's right. It's minus 3.
No, it was, yeah. And it's going to be on the other side is greater than 8b plus 3.
Ooh,
No, my bad.
super close. Super close.
Plus 12.
Plus 12. Thank you very much. Why is it plus 12, Brooke?
Because you have to multiply the 4 to both.
Yep, exactly. Any term inside those parentheses, you need to multiply, okay? It's not just 4 times 2. You also need to do 4 times 3. Very good. So we've got 8b minus 3, 8b plus 12. Now, remember when we talked about equalities, right? And I told you a light bulb should go off when you have the same term on both sides. Do we have that here? Okay, so same light bulbs going off for inequalities, okay? But watch very carefully what I'm about to do. Now, if we were to solve this normally, we would just subtract 8b from both sides, right? You agree? Okay, this would cancel, this would cancel. This is where things get tricky, okay? So look what we have. We have no b's remaining. We just have -3 is greater than 12. Now, we only have numbers now. We have no b, so we're done solving, right? But is this a true statement? Is -3 bigger than 12? Jonathan?
No.
Put a giant X, write false, and then how many solutions do you think this is going to have?
No.
Absolutely no solution, okay? There is no value for b that you could pick that would satisfy this inequality, okay? No matter what you pick for b, this is going to be no solution, okay? Now, the reason it's no solution is because -3 is not bigger than 12. 12 is the bigger number. Now, if it was written like this, right? Would that be a true statement? Yes, okay? But since we don't have that, we're going to see that in the next problem, okay? So this one was no solution. All right, take a look at the green one. Aya?
Why wouldn't you add 3 to both sides?
You could. Okay, great question, Aya. Aya asked, why don't we add 3 to both sides? You absolutely could. So let's say we added 3 as well. You would have gotten 0 is greater than 15, right? Because the -3 and the +3 would cancel. Is this true? No. So regardless of how you do this problem, no matter what manipulation, as long as you don't commit an algebra crime, you are going to be fine, okay? You're going to get the same answer. What's an algebra crime? An algebra crime would be if you added 3 to both sides and you got 16 is bigger than 15. I don't know how you would get it, but that would be a crime, okay? Because that's clearly not what we're supposed to get. All right. 2 times 5w minus 1 is greater than or equal to, less than or equal to 7 plus 10w. Light bulb. Grace?
Distribute 2 to the 5 and 1, which would be 10w minus 2 is the sign. 7 plus 10w.
Is the sign. Booyah! We got it right. Very good, Grace. Okay? I love that Grace distributed to both terms. That is what we're looking for. Love that for us. And then moving on, what are we going to do from this point? Nick?
Nothing, but it's no solution.
Hold on.
Wait,
We know it's going to be no solution or infinitely many. Why, Nick?
because they both have the same variable, but they have two different whole numbers.
Good. There's the same variable but 2 different whole numbers. Now, check this out, guys. When we were solving equalities, right? If I said if this -2 and the 7 don't match, we would get no solution, right? That is not true for inequalities, okay? That is not true because look what happens. Again, we're going to keep solving. Let's subtract 10w from both sides. Boom, boom. So what we're left with is -2 is less than or equal to 7. Now, look at that statement very carefully. Is that a true statement or a false statement? Victor? True, very good. Why?
Because 7 is bigger than -2.
Very good. 7 is indeed bigger than -2. Okay? So this is a true statement, and we have infinitely many solutions. If I could spell today, guys. Infinitely. I'm worried because I just spelled it wrong twice. Many solutions.
You have to write it out.
Could you guys imagine if I was your English teacher? That would be terrible. So on the right of your page, I want you to write down these 3 statements. 2 less than or equal to 7, -6 greater than or equal to 5, and 1/2 less than 1. And I want you over on the right to tell me whether it's a true or a false statement. You guys have 30 seconds. Go. Booyah. True, infinitely many. Now, we're going to rate true. Infinitely many would be if this was an inequality that we were solving for a variable, then that variable would have infinitely many solutions. You're absolutely right. Okay. What about number 2? Carson?
False,
Why?
because -6 is not bigger than 5.
Correct. -6 is actually a lot smaller than 5. And our last one, 1/2 is less than 1. JJ?
True,
True. Why?
Because 1/2 is smaller than 1.
Very good. 1/2 is definitely smaller than 1. Okay. On a number line, if 1 was over here, if 1 was over here, 0 was here, 1/2 would lie somewhere in between. Okay. So 1/2 is definitely smaller than 1. All right. Cool beans, people. Last part of our notes. Uh-oh. What? This is, oops.
Can you like go up a little because I was in the bathroom?
No, you can get it from a friend. Okay, we've got our word problem. Yay, it's our favorite. Okay, what I want you guys to do, listen carefully, okay? I need you to write down that this is our word problem. If you want to write on your page that this is your favorite part of the lesson, then do that, okay? And then I need you to write down the word problem, which is boxed in blue, and the chart over here on the right. All 3 of those things, okay? Label this the word problem section of your notes. Write down the word problem, and I need you to copy down that chart. Okay, now this word problem is a bit harder than what you're going to see on your homework and going forward. So we're just going to set it up. We're not actually going to solve this word problem, okay? So the word problem says you need a mean score of at least 90 points to advance to the next round of the touchscreen trivia game. What scores in the 5th game will allow you to advance? Let's take a look at that statement, and I want you guys to tell me what are important things that are mentioned in that statement. JJ, give me one of them.
you need at least 90 points to advance to the next round.
Very good. At least, oops, that's a line. At least 90 points to advance to the next round. So we already know that this is going to be an inequality. So let's write 90. And someone tell me, is 90 going to be a minimum? Is it a least value or is it a maximum value? Pedro? It's at least. So should our inequality face the 90 or face away from the 90? Away from the 90. Very good. Okay. 90 is going to be the least amount of points that we can score to advance. So whatever we're finding for the score, it needs to be bigger than that. Is that the bell? Wow. Okay. You don't. So 90 is going to be less than or equal to, because it says at least. So we could actually be at 90 points when we're done in order to advance to the next round. And then we're going to talk about games 1 through 4. Plus a game, which we're going to label X for game 5. Because it says we need to figure out what game 5 would be in order for us to advance to the next level. Now, the mean score needs to be 90. How do we find the mean? We have to add all these values together, 95 plus 91 plus 77 plus 89 plus X, and then divide by 5. This is all I wanted you to do for this problem, was set it up. Our variable is X. You can solve for it. If you do solve for it, you should get 98 is less than or equal to X. Okay? This is all our notes for today. That is lesson 2.4.